So here's our Monday revision solutions. It's from the 2016 Examcraft paper 2, question 1. And question 1, part A, is about a biology experiment. There are 50 seeds planted and 37 germinate. So I want to find the probability that 6 out of 10 particular seeds germinate. So this particular question is a Bernoulli trials question. So I've got seeds being planted and two things can happen. They can germinate or not germinate. So that's my success and failure. I want to start off by defining that. So don't forget, in Bernoulli trials, P represents the probability of success. We're defining success as germination. And then we have Q, and Q is defined as failure, and in this case, that's no germination. And I can figure out those probabilities pretty easily from the information that I'm given. So the chances of a particular seed germinating are 37 out of 50, and the chances of failure will just be 13 out of 50. Notice that the probability of success and the probability of failure sum to a total of 50 over 50, or 1. N is the number of trials in this calculation, and in part 1 we're trialing 10 particular seeds. So N is 10, and we also need to make a note of the number of successes that we want to happen in our set of experiments. So we're going to say, well, we want 6 out of 10 to germinate, so 6 is the number of successes here. And our formula that we want to look at is page 33 in our log tables, and it's this formula here, which is the formula for Bernoulli trials, or as they call it in the log tables, binomial distribution. Binomial distribution because there's two options, success and failure. That's where that word is coming from there. So we'll note our formula, n choose r, p to the r, q to the n minus r, and then it's simply a question of filling your values in. So 10 choose 6, p to the r, so that's 37 over 50 to the 6, and that's because I have got a probability here of success of 37 over 50, and I want that to happen 6 times, multiplied by 13 over 50 to the power of 4, and that's because if I'm going to have 6 successes, well then I'm going to have 4 failures. And then it's off to the calculator to type that in. And I get 0.1576. Just watch out for how many places of decimals they want in any particular question. This time it was 4. Part 2 is along the same theme. So we want to find the probability that the 8th seed is the 5th seed to germinate. And of course, don't forget again, germination is being counted to be a success in this particular scenario. So when we see questions like this where they want a success, a particular success, a 5th success on a particular item, so a 5th success here on an 8th seed, that's going to be the Bernoulli trials approach, but with just an extra added step. So we actually have to break it down a little bit. Even though they're talking about 8 seeds, I'm going to take a step back and look what happens with the first 7 seeds first of all. So in order for the 8th seed to be the 5th seed to germinate, in the first 7 seeds, I have to have 4 seeds successfully germinating. So out of those first 7, 4 seeds germinate, and when I get to the 8th seed is definitely going to germinate. So I'm going to do a calculation for the first 7 seeds, and I'll write down a probability for the 8th seed, and then of course I want both of those things to happen because I've got an and there, so and means multiplication, so I'll multiply my two probabilities together. Right, okay, so 7 seeds where 4 germinate, so it's back to this type of calculation here again now. Slight edit to my values, P and Q stay the same. I've got N trials, that's 7 in this case, and I've got R successes, that's 4 in this case. So now I'll fill it in to my binomial formula and get the answer for that. So that's 7 seeds with 4 successes. The chances of success is 37 over 50, and I want 4 of those to happen. Chances of failure are 13 over 50, and that's going to happen 3 times. That's all going to get multiplied by the probability that that particular 8th seed germinates. But we know from observation that the chances of any individual seed germinating are 37 over 50 from our relative frequency up here. So we're just going to multiply by 37 over 50. And we put it all into the calculator and get a result of 0.1365. And again, just note the number of decimal places that you need to round it off to. And so on to part B. So in part B, we've got a bag of marbles. We've got 3 red, 4 blue and X green marbles. And we're told that the probability of selecting 2 green marbles is 5 over 26, and we want to figure out how many marbles are in the bag. Well, the first thing that I'm going to note is that I'm looking exclusively at green marbles. I've got X green marbles, but of course when I want to work out a probability of selecting a particular colour from the whole bag, I need to know how many are in the bag in total. So to do that, I have to add up how many marbles of each colour there are, and the best I can do with this is 7 plus X. I'm taking the 2 green marbles straight out, so there's no replacement. So for the first marble, I have got X marbles that are green over a total number of 7 plus X. And then for my second marble, Well, I've removed a green marble, so I'm down 1 green marble, but I'm also down a marble overall, so I'm down to 6 plus X marbles in total in the bag. And of course, I know that the multiplication of these two fractions gives me a result of 5 over 26. And now it's just a question of doing a bit of manipulation to get the equation a bit tidied up and then solve for X. So I'm just bringing denominators across equal signs there to do a bit of multiplication. And I'm multiplying that out. And then of course it looks like it's going to turn into a quadratic. So I'll get everything to one side equal to 0. Ooh, I've forgotten an X up here. Just spotted it in time. So I'm getting my quadratic. That looks like a complete and utter pain to factorize. So minus b formula. Although I do actually think it is factorizable if you fancy having a go. I think life is too short. And we've got our values for a, b and c, and then in they go to our formula. So there's our completed formula. I'll get two results and they come out as 6 and minus 5 over 3. Now, fairly obviously, I can discard this answer because I can't have minus a number of discs or marbles or whatever they are, and also it's a fraction. So goodbye. Just watch out that you don't stop here because they wanted to know how many marbles are in the bag. So I have to just go ahead and say that the number of marbles then is just going to be 3 and 4 and 6. So we've got 13 marbles in the bag in total. Just a quick note to point out that this question can also be done using combinations if you like, but I think it's a little bit less obvious, and this is definitely the route that I would choose myself.